Nuclear energy is energy that is stored in the nucleus or center of an atom. In order to use this energy, it has to be released from the atom. The process of splitting the atoms is called fission, and that creates heat and radiation. Nuclear power plants use fission to make electricity. In Canadian CANDU reactors, uranium fuel supplies the atoms, and heavy water moderator, a denser version of ordinary water, slows down or moderates fast-moving neutrons, so they will split other atoms. The process of splitting uranium atoms produces clean, carbon-free electricity. The heat from this controlled chain reaction is taken up to steam generators, where it turns water into steam. The steam pressure drives the turbine generators to produce electricity. The steam is then cooled down in condensers and returned to the steam generators to be used again and again.
Called the gun barrel type, the uranium bomb's design was simple and foolproof. A small subcritical mass of uranium is secured at one end within a strengthened container and surrounded with a neutron reflector. A neutron initiator is placed beneath it, ready to emit a burst of neutrons and initiate the chain reaction. At the other end of the gun barrel, another subcritical mass of uranium in the form of several rings is positioned with conventional high explosives packed behind. Putting it simply, the explosives are detonated, driving the uranium rings down the gun barrel at high speed to the target uranium. Simultaneously, the neutron initiator fires neutrons into the mass to begin the fission process. Scientists were so sure of this device, they did not test it until it fell on the city of Hiroshima, Japan. The second fission design focused on compressing a spherical subcritical mass of plutonium into a small critical mass by way of conventional explosives surrounding the sphere. The core of the bomb is the neutron initiator, a small urchin composed of two materials, beryllium and polonium-210. When crushed, the two metals mix, emitting a burst of neutrons which initiate a fissile chain reaction. Surrounding the initiator is a shell of plutonium weighing about 6.2 kilograms, itself surrounded by a tamper of uranium-238. This tamper reflects neutrons back into the pit to help sustain the chain reaction. Surrounding the pit is a thin shell of boron plastic to protect the core from any stray neutrons. A thick aluminium pusher to compress the pit with the explosive shockwave was the next layer. The explosive composition B surrounded the aluminium shell. Cone-shaped baratol explosive lenses were positioned evenly around the sphere, and a final outer layer of more composition B. A containment vessel or soccer ball of duralumin with brass chimney sleeves retained the numerous explosive detonators. Firing of the explosive detonators milliseconds apart set off the lensing explosives. A spherical shockwave traveled inwards, compressing the aluminium pusher spheres. The pit, the initiator urchin, was crushed, releasing a spray of neutrons into the now critical mass of plutonium. This caused a fission chain reaction, sustained by the still expanding explosive shockwave holding the pit together, until the overwhelming energy released by the fission chain reaction expanded into an atomic fireball.